Hey kids, another video from Mr. Smith. Today we're going to be we're going to be finishing up our geometry unit volume of three-dimensional figures. We're going to be looking at the volume of rectangular prisms, um, triangular prisms, rectangular pyramids, and triangular pyramids. Okay, so those four things we're going over today, and shouldn't be too bad. Man, your volume of a sphere yesterday was way more intense than these guys are. Okay, so if you got through that, this is going to be a piece of cake. Also, it's just a lot of the same kind of math we've been doing with volume: length times width times height, and then divide it by something if there's a triangle in there. Okay, so not too bad. Hope you guys are doing well, staying safe. Sure miss you guys, but excited to make another video for you. Okay, so let's get started. Okay, the first thing we're going to go over today is the volume of a rectangular prism. A rectangular prism is any three-dimensional shape where all of the faces are made up of rectangles. Okay, so pretty straightforward. It's three dimensions, so that means we have a length and a width and a height. Our answer is going to be in cubic units, be that cubic meters or cubic inches. And the volume of a rectangular prism is pretty straightforward. Okay, it's literally just length times width times height. All right, so it's like finding the area of a rectangle, length times width, multiplying that by its height, and then you get a measurement of all the stuff inside of that rectangular three-dimensional shape. Okay, that height, that third element there, that third dimension really helps us calculate all of the space inside of that rectangular prism. Okay, so length times width times height. We have our example problem right here. So it has a length and width and height. You can interchange them just depending on which way the shape is sitting on. Whatever face the shape is sitting on is called the base, and the base can change depending on if you rotate the figure or not. So whatever face the figure is sitting on, that's called the base. Okay, and all of these, this will be finding the area of the base, okay, length and width. And like I said, length and width can be interchanged anyway. So it really doesn't matter what you call the length and what you call the width, so long as this is one dimension or two dimensions of that base. Okay, so in our example problem, it looks like it's like 2 wide and 6 long. So we would set up our equation like this. Okay, notice I'm using these parentheses to kind of hold the math that I want to do first. That's what the function of parentheses is in equations. It's just like, hey, do this stuff first. It's like your hands holding a section of the problem to do first. So the first thing we're going to do is find the area of that base, 6 times 2, and we're going to multiply it by the height. Okay? And what's our height? 10. Okay, pretty straightforward stuff. 6 times 2 is 12. And if my area of my base is 12 and I have 10 layers of it, then I'm going to multiply 12 times 10 to find the volume. Okay, so the volume of this rectangular prism is 120 centimeters cubed, or cubic centimeters. I think in IXL, you just literally type this in and it says cubic centimeters. All right, volume of rectangular prism, not too bad. Let's move on to the next one. Okay, now this one is still a rectangular prism. It just has all of its faces are squares. Okay, so it's a special type of rectangular prism called a cube. Okay, so just like a square is a special rectangle, a square is a rectangle. It just has all sides equal. A cube is a special rectangular prism. It's just kind of the most common rectangular prisms we mess with or come in contact with in our real world situations. And so we tend to think that a cube is separate from a rectangular prism. It's the exact same. So same formula for a cube, volume equals length times width times height, except with a cube, since all of the sides are the same, we tend to see a formula that looks like this. So S stands for side. So the volume of a cube is side times side times side, or a side length to the power of 3. Okay, and in this particular cube, all of the side lengths are 9, what is it, in inches? So they're all 9 inches, so basically our formula looks like this. Okay, so you just take that any side length, raise it to the power of 3, and you get 729. Notice that that's not 9 times 3. It's 9 times 9, 81, times 9, which is 729. So then, it's in inches, right? So we have volume equals so volume equals 729 inches cubed, or in IXL, cubic inches. Okay, so you're going to run into a lot of cubes in IXL. Quick shortcut is just take a side length, raise it to the power of 3. Okay, this next one is called a triangular prism. Still in the prism category, except a triangular prism will have a rectangular base. We'll have a couple of rectangular sides, and then a couple of triangular sides fit into it. So a triangular prism has 2 triangle faces, and looks like it has 3 rectangular bases. Of course, you could take that triangular prism and stand it up so that its base is a triangle, and then it has rectangular sides. But we generally think of triangular prisms as laying on its rectangular base and having those 2 triangle end pieces on there. Okay, so still definition of a prism. And this triangular prism, we're going to find the volume the same as a rectangular prism. Just at the end, we're going to divide it by 2. Okay, and that really ties into, when you're finding the area of a triangle, you basically find the area of a rectangle, and then you cut it in half, because a triangle is half of a rectangle. So same formulas we've been dealing with, but let's just give it a try. Okay, so like I was saying, we find the volume of a rectangular prism, and then we divide it by 2 because it has those triangle end caps on it. So the one we're using with looks like it has a base rectangle. So like this is the area of the rectangle that we're looking for, and it looks like it's 4 wide by 9 long. Okay, so this is just the area of the base it's sitting on. Volume equals 9 times 4 times the height divided by 2. So plug those in. Okay, so the volume of this triangular prism, we first want to look at the base. The base is a 9 by 4 rectangular base. We want to find the area of that first. And then we multiply that by 6, because that triangle is 6 centimeters high. So we multiply that by 6. And then we're going to divide it by 2, because it is a triangular prism, not a rectangular prism. So then we're just going to cut that in half, and we'll get the volume of the triangular prism. So all this works out to be So all this works out to be 216. Then we're going to divide that by 2 because it is a triangular prism. And then when we get that, our volume of that triangular prism is 108 centimeters cubed, or cubic centimeters. Okay, so just divide by 2 on those triangular prisms. Okay, now we're moving into the realm of pyramids. Pyramids are different than prisms because pyramids have all triangular faces. If it's a rectangular pyramid, the base is a rectangle or a square, and all the faces are pyramids. Or if it's a triangular pyramid, then all faces are triangles. Okay, so pyramids are going to have a lot of triangles involved and then one rectangular base. So this is the rectangular pyramid that we're working on. Here is the formula for the rectangular pyramid. If you notice, it's very similar to the triangular prism, except in the rectangular pyramid, we divide it by 3. And that kind of ties into our volume of a cone. So a cone and a rectangular pyramid are pretty similar in how they're made up. And so that's where that divide by 3 comes in. I was looking up, where does that divide by 3 come from? It's from that 1/3, right? So 1/3 times the base, times the length, times the width, times the height. And then last week, instead of doing 1/3 times all that stuff, we just did all that stuff and divided by 3. But I was looking up on the internet, I was like, where does this 1/3 come from? And there's not a real straightforward answer to it. What I was able to find is, like, if you take a cube and you make a bunch of rectangular pyramids inside of the cube, I guess you get like 6 of them. And then if you only want one of them, then it's 1/3. Just stick to the formula, you'll be fine. Okay, so let's work through this example problem of a rectangular pyramid. Okay, so by substituting the length and the width of the base, because remember, the kind of key of finding the volumes of all of these 3D shapes is first finding the area of the base. And the base of a rectangular pyramid is a rectangle. So we want length times width to find the area of that base that this rectangular pyramid sits on. We're going to multiply it by 9, which is the height of this rectangular pyramid. And then after all that, we're going to divide it by 3. Okay. Now, if you mess up on IXL and it shows you how to do it, they use the same kind of formula we used last week when we did volume of cones. And I'll write that out for you real quick just so you see it. All right, so it'd be like 1/3 times 6 times 5 times 9. And with the volume of a cone, we kind of did all this multiplication first. And then we said, well, if we do 1/3 times that, we set it up into 2 different fractions. We multiply it straight across for a long, bunch of steps to get to. You really just multiply everything and divide it by 3. So we're going to use this shorter version of the formula for this lesson. Like I said, if you mess up on IXL, they're going to show you this. They're going to show you this 1/3 times 6 times 5 times 9. And then they kind of just cut to the answer. They don't really show you how you do this 1/3, how you multiply 1/3 by those things. So just know that these are equivalent equations, okay? Okay, so when you multiply these out, you're going to get 270, and then we divide it by 3. Because of that, same idea as the volume of a cone. We just divide that by 3. We don't divide it by 2 because it's not a triangular prism. It's a rectangular pyramid, so we're going to divide it by 3, okay? Okay, and then we're going to end up with 90 centimeters cubed, or 90 cubic centimeters. Okay, the last thing we're going to look at today is a triangular pyramid. So a triangular pyramid is made up of all triangles. This one gets a little, and there's another extra step to it because we find the area of the base like we have been. But this base is a triangle, so we have to remember, I think it was like sixth grade geometry, where the area of a triangle is just half of the area of a rectangle. So not complicated, it's just another step. All right, so here's our example problem. Here's the formula for the volume of a triangular pyramid. And notice in the formula it says volume equals the area of the triangular base times the height, and then we divide it by 3 because it's still in that like volume of cone realm where there's these weird triangular shapes inside of a volume. So we always divide those by 3. So the volume of a cone, we divide by 3. The volume of a rectangular pyramid, we divide by 3, and the volume of a triangular pyramid, we divide by 3. So volumes of pyramids are divided by 3, volumes of cones are divided by 3, but the prisms, if there's a triangle, you divide it by 2. Okay, so let's just get into this triangular pyramid here. Okay, so this formula says the volume of a triangular pyramid is the area of the triangle base times the height divided by 3. So this 6 times 4 divided by 2 is how you'd find the area of that triangle base. It's got a length of 6, the width of 4. So you do 6 times 4, but then you cut that in half to get the area of that triangle. Multiply that by the height of that triangular pyramid, and then divide it by 3 to get the volume of the triangular pyramid. Okay, working through the math here. 6 times 4 divided by 2 is 12. 12 times 8 divided by 3. 12 times 8 is 96. 96 divided by 3 is 32. So the volume of this triangular pyramid is 32 millimeters cubed, or 32 cubic millimeters. Okay, so I guess of all of them, trying to find the volume of a triangular pyramid just has the most steps in it. Like I said, it's not complicated math, but there's a lot of, it looks like there's a lot going on in here. But that's it. Those are all of the ones that you're going to find on your IXL. Getting into the 80s and 90s on IXL, you will find those problems where they give you the volume and they'll say like, find the height or, find the length. And you're going to have to really get deep into some algebra, isolating that variable. So if you get to those, we're just using algebra if they give you the volume, we're just using algebra to work our way back to finding the height or the length or the width. But reach out, take a screenshot of it, send it to me, in my Google Mail. What I've been doing with those kids that have been doing that, I have this pad that I can write on. So I'll just write some notes on it and send it back. And I think most of the kids have been pretty successful just kind of getting a direction in that algebra. But if you're ready for a challenge, seek those ones out and practice using that algebra. That's some good 8th grade math that's going to get you ready for some high school math. Okay, so good luck on this assignment and reach out if you need some help.